and welcome to our very first lecture. During this course, you're going to gain the ability to write awesome bash scripts. But to do that, we first need to cover some very important key concepts. In this video, you're going to learn what the bash shell is, as well as the difference between the shell and a script. You'll also learn why bash is more popular than other shells and why scripting is a helpful thing to be able to do in the first place. By the end of this video, you'll be able to explain the difference between shells and scripts, explain the benefits of using the bash shell in particular, and explain the benefits of using scripts in general. So this is all very exciting stuff, so let's go ahead and get right into it. So what is the shell? Well, the shell is simply a program that interprets the commands you type in your terminal and then it passes them on to the operating system. The shell is something that you, as a human, can use to give instructions to your computer. The shell will interpret these human-readable commands and cause your operating system to do what they say. In short, the purpose of the shell is to make it more convenient for you to issue commands to your computer. There are many different types of shells, but in this course, we're focusing on the bash shell, which is the most popular shell. Throughout the course, I'll simply use the terms bash and the shell interchangeably. Bash stands for the born again shell. Interestingly, its name is actually a fun joke. Bash is based on a much older shell called the Bourne shell, or SH, which was created by Stephen Bourne in 1979. Since bash is an improved version of the Bourne shell, people thought it would be funny to call it the born again shell, or bash. As I said earlier, bash is the most commonly used shell, and the reason for this is the advantages that it has over other shells. First, bash has a very broad set of features available, which makes it convenient to work with and capable of achieving pretty much anything you could ever want to achieve when interacting with your operating system. For example, the Bourne shell, which bash is based on, lacks a lot of features due to the fact that it has not been broadly developed. Other common shells, such as the C shell and the Corn shell, each have their benefits, but do not contain as many features as the bash shell. Bash is also considered to be a fast shell when compared to other types of shells, which makes it more convenient to work with and makes it quicker to execute commands and less of a drain on your system's resources. Finally, the bash shell is the most commonly used shell, and due to the variability of Linux systems, this is a major benefit in itself. By writing scripts for the bash shell, you can be rather confident that your script will work when you pass it to other machines, which can save you a whole lot of work. Okay, so now we understand what a shell is. What is a shell script? Well, a shell script, or script for short, is just a file containing a series of commands that will be run by the shell. The shell reads the script and executes the commands, one by one, as if you'd entered them into the command line yourself. A bash script, therefore, is simply a script written for the bash shell, and we'll see how these are built in the next video. So why use a script? Well, the main reason is that writing scripts allows automation. Imagine that you have a set of 20 commands that you need to run to perform a task, and you want to run them once a week. How much work is it every week for you to type out those commands into your command line? What happens if something goes wrong and you break something by typing the command incorrectly? And what happens if you forget to do it one week and get an angry email from your boss? Well, this is where scripts come in. Scripts can be automated to run at a specific date or time without you having to remember to run them, and you'll actually see how to do this later in the course. Scripts are convenient ways to store sets of commands that allow you to automate tasks, save time, and increase reliability. And remember, bash scripts are just bash commands in script form. This means that, as an added bonus, much of what you'll learn in this course will be directly applicable when you work with the regular bash command line, which will improve your effectiveness and productivity no matter how you interact with your Linux machine. So in this lecture, you learned that the shell is a command line interpreter that makes it easy for you to issue commands to your operating system. You learned that the bash shell is a great shell to learn because it's fast, has a lot of features, and is very commonly used. You learned that a script is just a file containing commands that are to be run by a specific shell. So a bash script is simply a file containing bash commands. You also learned that scripts make automating sets of commands very convenient, which saves you time and makes you more productive. So now that you know what a bash script is, let's learn how to write one. In the next video, we're going to cover the core components of bash scripts, and you're also going to build your very first script for yourself. So for all that good stuff, I'll see you in the next video. Hello there, you beautiful people. Now, in the last video, you learned the difference between shells and scripts. You also learned the advantages of using the bash shell in particular, as well as the benefits of writing bash scripts. Now we're going to take a closer look at how to write the scripts themselves. In this video, you're going to learn about the core components of a bash script, and you'll also learn how to run a script on your computer. By the end of this video, you'll be able to identify the core components of a bash script, you'll be able to explain what these core components do, and you'll be able to actually run scripts on your computer. All very exciting stuff, so let's get into it. Okay, I want you to think of a bash script as being kind of like a script for a movie or a theatre performance. And just like the scripts that are written for movies or theatre performances, the scripts we write in bash have three core parts: a beginning, a middle, and an end. Our bash scripts always begin with what is called the shebang line. The shebang line is always the very first line of a script, and there must be no line or blank line before it. The shebang line basically tells the shell what interpreter should be used to read the file. You can think of it as telling the shell what language the script is written in, which in our case will be bash. The shebang line starts with a hash symbol, immediately followed by an exclamation mark, or a bang. To make it more convenient for people to say, the hash bang pattern is usually shortened to shebang, which is where the shebang line gets its name. Immediately after the hash bang part comes the path to the interpreter that is used to read our file. Since we're writing bash scripts, we give the path to the location where the bash shell is installed on our system, which will always be /bin/bash. Now, since we're discussing script structure, let's go ahead and write our shebang line in a script and then move on to discuss the other core parts. Just to mention at this point that, for the sake of simplicity, I'm going to be using the Nano text editor during this course to view and edit our scripts. However, you can feel free to follow along using any text editor that you like. If you're not sure, or you're kind of new to this kind of thing, Nano is a pretty user-friendly choice, so I recommend going with that and following along using Nano. I've also created a folder in my home directory called Bash Course, where I'll be putting all the scripts that we write in the course. I suggest you do the same to make it easy to follow along. You can simply create the folder using the make directory or mkdir command by running mkdir:/bash course. Okay, let's open our first script with the Nano editor. We simply move to the bash course folder using the cd command, and then I'm going to use Nano to create a file called our first script. Awesome, we've got our script and we're ready to go. So let's write our shebang line. It's very easy. We just type #bang/bin/bash at the top and save our file. On Nano, you can save the file using Control and O or Command and O if you're on a Mac. Our system now knows that we have a bash script. If we close this file, on Nano you can close the file using Control and X or Command and X if you're on a Mac. We can see what type of file our shell thinks we have using the file command. If we run the file command on our script, we can see that it says that we have a bash script. However, if we go inside and change our shebang line to a path to the Python interpreter, which is /user/bin/python3, and then we save the file using Control and O, and exit using Control and X, and then we run the file command on our script once again, we see that the shell now thinks that we have a Python script. Cool, right? Let's open the script again and change our shebang line back to the one needed to write a bash script, which is #bang/bin/bash. Okay, so the second core feature of our bash script is the actual bash commands themselves. Now that we've told the shell which interpreter to use, we can now start to give it some commands to interpret. As we explained earlier, a script is simply a file containing commands for the shell. For our first script, we're going to use the echo command to print out text to the screen. We usually leave a blank line after the shebang line for formatting reasons, so go ahead and leave a blank line using the Enter key and then type echo, "This is my first script" on the next line. Bash scripts can have many commands and many lines. Each line is read by the bash shell and executed one after another. So the sister component, I guess, of learning bash scripting is learning what bash commands are actually available to you to use in the script. And you'll learn a lot of those throughout the course. Now, the final core component of a bash script is the exit statement. Just like a movie script, the exit statement tells the shell that the script has ended. However, by entering different exit codes, the exit statement also tells the shell whether the script has completed successfully or unsuccessfully. Exit statuses can have any value from 0 to 255. To say that the script has executed successfully, we simply give the script an exit code of 0. Any non-zero exit code tells the script that something went wrong in some way. Most of the time, we just use an exit code of 1 to say that something went wrong. An exit code of 1 represents a generic error, a miscellaneous error, if you will. However, some exit codes have special meanings, and knowing these can help your scripts to play nice with other programs. I've put a link in the resources section to some documentation on what these exit codes are and what they mean, which you can check out if you're interested. Since it's kind of hard for our script to go wrong, we'll just give it an exit code of 0. To give our script an exit code, we use the exit command. At the bottom of our script, we're going to simply type exit 0. And that's it. When our script gets to this line, the script will end and give an exit code of 0 back to the shell. Note that you're not always required to place an exit status in your bash script. Although it's very helpful to define one yourself, if you choose not to add an exit status, the shell will simply take the exit code of the last command it ran as the final exit code of the script. You can now save your script and go back to the terminal. And now for the exciting part, actually running our script. Because Linux focuses a lot on security, in order to allow our script to run, we have to give our script what are known as execute permissions. Fortunately, this is very easy to do, but how you do it matters for the security of your system. We're going to touch on script file permissions in more detail a little later, but for now you can just run the chmod +x, our first script, to give the script execute permissions. If we run the ls command, we can see that the script has been highlighted on my screen in red, which shows that the execution permissions have been set. You might have a different color on your screen if your terminal has different stylings to mine. I believe the default color is green, but the important thing is that the script will look different to regular files when it has been given execute permissions. Now let's run our script. To do this, we simply give the path to the script. Since we're in the same directory as the script, we can just type /our first script. The / means in this directory, and our first script is obviously the file that we want to run. When we hit enter, we see the text, "This is my first script," printed out on the screen. So congratulations, you've now written and executed your very first bash script, all in under 10 minutes. In this lecture, you learned that bash scripts are kind of like movie scripts. They have a beginning, a middle, and an end. The beginning of a bash script is the shebang line, which tells the shell what type of script we are writing. For bash, our shebang line will pretty much always be #bin/bash. The middle of a bash script is the commands. This is where the show actually happens. And the more commands you know, the more varied the scripts you can write. But don't worry, we'll be covering a lot of useful commands in this course. The end of a bash script is the exit code. The exit code tells the shell whether the script ran successfully or unsuccessfully. Finally, you learned how to run your bash scripts by giving them execute permissions with the chmod command. So now that you've learned the core components of bash scripts, let's take a look at some stylistic things you can add to your bash scripts to make them look more professional. So for all that stylistic flair, I'll see you in the next video. Hello there, you beautiful people. Now in the last video, you learned about the 3 core components to a bash script, and you even created and ran your very first script. Now we're going to take a look at some stylistic components that you can add into your bash script to make it look professional. In this video, you're going to learn about adding comments to clarify your code and how to add extra information to give your scripts a professional touch. By the end of this video, you'll be able to create inline comments to clarify pieces of your code, add author information to claim the work as your own, add date information to let people know when the script was created and when it was modified, add description information to your scripts to let other people know what your script does, and add usage information to let other people know how to use your script. So let's go ahead and get started. Now, I'm a big fan of learning one thing and being able to use it for multiple different purposes. So if you're like me, then you're going to love this lecture. The key thing we need to learn in this video is commenting. What is commenting, I hear you ask? Well, commenting is a general programming technique that allows you to add human-readable comments to your scripts. Unlike commands, comments are not meant to be read by the shell. They're meant to be read by the humans who are looking at your code. Essentially, comments are intended to clarify your script and make it easier for people to read and use, whether that be your colleague or yourself a few weeks later when you've completely forgotten how your script works. To help Bash know which lines are commands and which lines are comments, we need to start our comments with a special symbol. In Bash, we indicate comments with a hash symbol. When you start a line with a hash symbol, the shell knows that the line contains a comment, and it will simply skip that line and move on to the next one. The most common way of using commenting is to explain what certain sections of your code do. Now, with our small script that we've developed, commenting might not be totally necessary. It's only one line after all. However, as we continue through the course, you'll begin to appreciate how good commenting can be a very helpful tool. To give an example, we can add a comment to our script like this. Now, if we save the file, and then we run it, we can see that the comment is totally ignored by Bash, and the script runs just fine. Aside from explaining sections of our code, we can use comments to add some useful information that describe our script as a whole and make it look more professional. To make your script more professional, you can include 5 pieces of information. These are the author, the date of creation, the date the script was last modified, the script description, and the script usage. Firstly, let's discuss the author. This is simply your name. To add yourself as the author of the script, you would simply come up to the top below the blank line beneath the shebang line, and you'd then type a hash to indicate that the line is a comment, then a space, then type author with a colon, followed by a space, and then type your full name. So in my case, I type hash author Ziad Yahya, and this allows the future user of the script to know that I wrote it. Awesome. Our script now has an author, and the second piece of professional information that you can add is the script's date of creation. Here, you just write date created, and then type in today's date. The third piece of information is the date the script was last modified. Just like before, we'd start the line off with a hash to indicate that it's a comment, then type last modified, and then enter the date that we last worked on the script. You just need to remember to update this line whenever you modify the script so that people can know how old or how up to date the script actually is. Fourthly, you can put in a description of what the script does. This is really useful for jogging your memory or for easily getting someone up to speed on what the script does without forcing them to read the whole code first, which is really, really helpful. In our case, our script is just printing some text to the screen, so we can just type hash description, and then on a new line type prints "this is my first script" to the terminal. Because it can get quite long, it's usually a good idea to leave a blank line above and below the description section for readability purposes. Finally, we can enter in some usage details for our script. Usage information simply tells the user how to actually use the script, what they should type in their terminal to use it properly. Just like a man page or manual page for regular commands, we use the usage area to let our users know if the script takes any options, whether it requires any command line arguments, and so on. Our script is actually very simple to run, so we'll just write our usage information like this. We'll first put a hash, then write usage, and then on a new line, we'll write our first script, again leaving a blank line above and below the usage section for readability. As a side note, with more complicated scripts, you might need more advanced usage information, just like how you get in the synopsis section for a man page. If you're interested, I've put a link in the resources section to the official standards on how to structure usage information for complex commands, but reading that is totally optional. And that's it. We now have 5 really cool pieces of information that help make our scripts look super professional. Great job. Hey, you're starting to look like a bash scripting pro already. So in this video, you learned how to add comments to your scripts to clarify your code, as well as how to add 5 pieces of information to your scripts to make them super professional. The script's author, creation date, last modified date, description, and usage. So now that you know all 3 components of a bash script and how to structure your bash scripts professionally, in the next video, we're going to have a quick discussion about security, and then you'll have a challenge to write your own bash script independently. Once again, very, very, very well done. You're making loads of progress in such a short amount of time, and I'll see you in the next video. Hello there you beautiful people, and welcome to this video where we will be discussing a very important topic: security. In the lecture on the 3 components of a bash script, you learned how to give your scripts execution permissions so that your system will allow them to run. However, we left an intentional mistake in the way that we did things last time that could potentially impact the security of your system. In this video, you'll be learning about Linux file permissions and how to set permissions on your scripts correctly so that you don't accidentally introduce any security holes. By the end of this video, you'll be able to identify different file permissions, interpret what they mean, and keep your script secure by setting the right file permissions for your particular context. This is all very exciting stuff, so let's get into it. So what are file permissions? File permissions are what determine who can perform certain actions on a given file. To view file permissions, we can run the ls-l command. As you can see, this has listed out the contents of your current folder, along with the permissions for each entry. In Linux, file permissions are represented by a set of 10 characters strung together. The first character stands alone, and the remaining 9 are broken up into 3 sets of 3. The first character is either a hyphen or a D. If it is a hyphen, which is this minus sign, then the entry is a file. If it is a D, then the entry is a directory, i.e. a folder. The next set of 3 characters represents the permissions that the file's owner has for the file. The file owner is shown in the third column, which on my system says Ziad. The first character in this set of 3 is for read permissions. If the file owner has read permissions for the file, we will see an R there. If they don't, we'll see a hyphen. The second character in this group of 3 is for write permissions. If we see a W there instead of a hyphen, it means that the file owner can modify the contents of the file. The third character is for execute permissions. If we see an X there, then the file owner has execute permissions for the file and can run it like a script. The other 2 sets of 3 have the same format, but represent different classes of users on the system. While the first set represents the permissions for the file owner, the second set represents the permissions for the file's group. The file's group is shown in the 4th column, which in this case is the Ziad group. The third group of 3 represents every other user on the system, so every user who is not the file owner and who is not part of the Ziad group. Now, for bash scripts, it is recommended that unless there is a particular reason otherwise, only the file owner should have the ability to read, write, and execute the file. Everyone else should only be able to read it. By not allowing anyone else to write to the script except the file owner, we prevent others from making sneaky changes to the script without the file owner's knowledge. If they did make these sneaky changes, then the file owner could end up running some code on their computer without knowing, and that could possibly have security implications. Secondly, by not allowing anyone but the file owner to run the script, we can stop unwanted and unintended uses of the script on the system. If we take a look at our script as it is, by changing directory and running the ls-l command, we can see that pretty much everyone has the permission to run this script. Now, under the wrong conditions, this could become a security problem, so let's learn how to make our scripts more secure. To give our script the recommended permissions, we use the chmod command like so. We type chmod, then 744, and then our script name, which in our case is our first script. I'll explain what this 744 thing is in a moment, but for now let's just look at the effect. When we run ls-l, you'll see that our script now has much more secure permissions. Only the file owner has all permissions, whereas everyone else can only read the file. In other words, no one but the file owner is allowed to modify the script's content or to run it. So what is this 744 thing? Well, 744 is called an octal number, and the chmod command uses these as a way of expressing which permissions should be set. However, octal numbers can be a bit confusing to read. Fortunately, there's a useful website called permissionscalculator.org which makes them super easy to interpret. If we head over to permissionscalculator.org, we can see that we are presented with a simple user interface where we can select the permissions we want, and it will tell us the appropriate octal number to type into the chmod command. So let's say we wanted to give everyone read, write, and execute permissions, and I click all these boxes. You'll see that we get 777 as the appropriate octal number. The 0 at the front here is kind of like a bonus digit, so we don't generally tend to include that. You can see that that 0 is governed by what they call the special flags in the octal number. But seeing as we're not going to use any of those, and we generally don't use any of those, we tend to just read octal numbers as 3-digit numbers. So in this case, we'd read this as just 777. If we run chmod 777, our first script, and then do ls-l to see the permissions we've set, we can see that, as we'd expect, everyone now has all permissions enabled. So, as a micro challenge for you, pause the video now and try to see if you can make it so that nobody at all can either read, write, or execute the script. So go ahead and pause the video now, try to make it so no one can read, write, or execute the script, and then come back to see how you did. How'd you get on? Well, if we go to permissionscalculator.org, it tells us that in order to make it so that no one has any permissions on the file whatsoever, and we can check that by unticking all of the boxes, we need to do chmod 000 our first script. And if you did that, then well done. It can be fun to see what it's like to not be able to read your own files, so have fun playing around with the permissions a bit. When you're done, just be sure to change your permissions back to the recommended permissions of 744 so that we can continue with the course. So, before we wrap up, let's have a quick recap of what we covered. In this video, you learned how to read Linux file permissions and interpret what they mean. You learned how to change permissions on your scripts with the chmod command and octal codes. And you learned the recommended permissions to use for your scripts for security purposes. In this video, we recommended that you use the octal code 744 unless you have a particular reason otherwise. But you might also like to use 755, which allows other users to read and run the script, but not to edit it. As a final note, it is worth bearing in mind that if you want to give someone execute permissions, you must give them read permissions too. Otherwise, their shell won't be able to read the script and therefore won't be able to execute the commands it contains. So do bear that in mind. So after the last few videos, you now know what a bash script is, what the major components of a bash script are, how to write your bash scripts professionally, and how to set secure permissions on your bash scripts. You've been making excellent progress, and I'd say it's about time for you to give it a go yourself. In the next section, you'll do your first challenge, how exciting, where you'll be challenged to write your very own bash script from scratch. I hope you're excited, so for all that good stuff, I'll see you in the next video. Hello there, you beautiful people, and I hope you had loads of fun trying out this project and building your very first bash script by yourself. If you managed to complete the project, then a massive congratulations to you, and if you struggled a bit, then well done for putting in the effort. In this video, I'm going to walk you through the model solution step by step so that you can see exactly how I would have gone about it, and you can also grab a copy of the completed script from this video's resource section. So let's get started. So the first thing we're going to do is we're going to create our script file by typing nano backup script. As we learned during the previous videos, there are three core components of our bash script. There's the shebang line, the commands, and the exit statement. So let's start at the top with the shebang line. For this, we can simply type hash bang /bin/bash, and that's it. The shebang line will pretty much always be the same for your bash scripts, so you can just commit that to memory if you like. Next, we have our commands. Now for this challenge, we've been very conveniently provided with the command that we're supposed to use for this script. So, on a new line, we can just copy and paste or type that command in. So that takes care of the commands. And finally, we just need to add our exit statement. If the script gets to the bottom, we're pretty sure it will have run successfully, so we just want to tell the shell that as well. You learned that the only exit code that means a successful run is exit code 0. So all we have to do is type exit 0. And that takes care of all the core components. We have a shebang line, our command, and our exit statement. So we should now have a fully functioning script. Remember that the exit statement is optional, but it's good to get in the habit of putting it in where we can. Now, because our boss wants to share this script with our colleagues, they've asked us to add the 5 professional components to our script, which are the author, the date created, the date last modified, the description, and the usage. These are all pretty easy to add, so let's add them in now. As shown in the previous lectures, these should go between the shebang line and the commands. So let's just move back up in the script a little bit, and remember to create a blank line after the shebang line to keep everything nice and tidy. So let's start with the author, which will allow us to stake our claim on our script and get credit for our work. So we just type hash, then author, and then our full name. Then we will add in the date that the script was created, and the date the script was last modified, which in this case will be the same date. Next, we will add in our description. Now, as we mentioned earlier, it's always good to leave a blank line first to keep things tidy. So let's do that, and then let's add in our description. Finally, we want to add in our usage. As our script doesn't take any options or command line arguments, we can just put the name of the script for this. And now we've successfully created our professionally formatted script, which is step 1 in this challenge. So well done if you got this far. So step 2 is to give our script the correct permissions. Now our boss has given us some rather specific permissions that we need to give the file. The file owner, which is us, has read, write, and execute permissions. The file's group, which is our colleagues, can read and execute the file, but no writing. And everyone else can only read the file. So let's head over to permissionscalculator.org to see what octal code we will need for this. Okay, so if we give the file's owner all permissions, and the file's group read and execute permissions, and everyone else just read permissions, we can see that the appropriate octal code for this is 754. So that is what we'll use. So let's head back to our terminal and type chmod 754 backup script. And if we run ls-l, we can see that our script has the conditions we expected. The owner has read, write, and execute permissions. The group has read and execute permissions. And everyone else just has read permissions. Great job. The only thing that remains now is to run our script. So if we head to our bash course folder and we type backup script, and then we take a look at our bash course folder again, we can see that we now have a backup file created. Awesome. Now if we run it again and check again, we can see that our script has created another backup, which is marked with the date and time down to the very second that it ran. I'm sure your boss will be very pleased indeed. Now from this, hopefully you can see that using bash scripts is a very helpful way to make your life a lot easier. In fact, feel free to play around with this backup script and customize the folders it works on to do something useful on your system. So I hope you had fun, and I'll see you in the next video where we'll be learning about how to make scripts like these accessible from anywhere on your system. Hello there, you beautiful people. So I hope you had a lot of fun in creating your very first script and in completing the last challenge. You've honestly learned loads of stuff already, and in this video, we're just going to focus on making your scripts just a bit easier to use. Until now, we can only run our scripts when we are in the folder that contains them. But in this video, we're going to make it so that you can run your scripts no matter where you happen to be on your system. In this video, you're going to learn what the system's path variable is and how you can modify it to make it possible to run your scripts from anywhere on your system, just like you would with regular commands. By the end of this video, you'll be able to explain the purpose of your system's path variable, you'll be able to add new folders to your system's path, and ultimately, you'll be able to run your scripts from anywhere on your system. So, for extra command line comfiness, let's get started. So what is your system's path? Well, in Linux, the system's path is a variable that tells the shell which directories to search for executable files in. When you run a command in your terminal, the shell looks for that command in the directories defined in its path variable to see if it has a command that it can run. If it does not find an executable file with the same name as the command anywhere in the directories, then you will get a command not found error in your terminal. The benefit of adding your scripts to your system's path is that they then can be run from anywhere in your system simply by typing in the name of your script, just like regular commands. We can take a look at our system's path by running the command echo $path. Here we're seeing some rather terrifying output pop up on the screen, but it's really quite simple. All it is just a set of paths to folders, each separated by a colon. When we enter a command name or script name into the shell and press enter to run it, the system will start at the far left of this list and work its way through each folder looking for an executable file with that name and run the first one that it finds. While we could add our scripts to any one of these folders, we're going to create a new folder in our bash course directory and add it to our path. I'm currently in the bash course folder right now, so let's make a new folder here called scripts by running the mkdir command. And we're going to use this new folder to store our scripts. Now, we need to add our script to this folder. So let's move it in there. Okay, and now we're almost there. Now we just need to add this folder to our path so that the system will know to search it for scripts. The system's path is actually edited using the .profile file inside our home directory. The .profile file contains many configuration details for the bash shell, which the shell reads when it starts up. So let's head over to our home directory using cd and open our profile file by running nano /.profile. As a side note, this is actually a hidden file. What that means is, if you run a normal ls, it won't show up, but you can still see it if you run ls-a, where the -a option means all. Hidden files are just Linux's way of making it so that the configuration files your system uses don't clutter up your view in your home directory. Now, if we scroll down to the bottom of this file, we can update our path by adding in export path equals, then open some quotes, $path, $home, /bash course, /scripts. Now what this does is overwrite the path variable to include our scripts folder at the very end of our path. This is a good place to put it because it means that on the one-off chance that we give a script the same name as a command that is already installed on our computer, like ls or something, those other commands will be given priority because they're further to the left, which can save us from unwittingly running into system-wide trouble. Okay, now let's save and exit the file. Now the .profile file is usually read when our shell boots up. If we want our shell to read the new version of the file, we have two choices. We can either reboot the shell by restarting our terminal, or we can use the source command to reload the file. The source command is usually the more convenient method, so let's use that. If we run source /.profile, this will cause bash to reload the .profile file. Now if we take a look at our path again, using echo $path, we can see that our path has been successfully updated to include our scripts folder. Great. Now because our first script is in our scripts folder, we can now run it from anywhere on our system. For example, we're currently in our home directory, but if we just type our first script, we can see that it runs perfectly. Awesome. Now whenever we want to add a new script to our path, all we have to do is move it to that folder and ensure that the script has execute permissions, just like we saw in the previous videos. For example, if we move back to our bash course folder, and we move the backup script that we created in the last challenge into our scripts folder, and then we move back to our home directory, we can see that we can run our backup script just fine without needing to be in the same folder as the script. It's really as simple as that. So to recap, in this video, you learned that the path variable tells the shell which directories to search for executable files. You've learned how to add folders to your path by editing your .profile file, and you learned that by placing scripts inside any of the folders on your path, you can make them easily accessible no matter where you are in your system, in the same way that built-in commands are. It's useful to point out that you should also try, wherever possible, to avoid giving your scripts names that may conflict with any pre-existing commands on the system. Other than that, well done. You've come a very long way in such a short time and have now completed the first section of the course. To make sure that you've got everything, in the next video we're going to summarize all that you've learned during the first section and give you a super shiny section cheat sheet. So for all that good stuff, I'll see you in the next video. Which you can download and refer to whenever you need to. I'll be doing that at the start and end of each section of the course from now on, so you've always got the notes ready to hand. So with all that said, let's have a recap. In this section, you learned that bash scripts have three core components: the shebang line, the commands, and the script's exit statement. The shebang line tells the Linux operating system which interpreter should read this particular script. In essence, it tells Linux which language the script is written in. When you are writing bash scripts, the shebang line will pretty much always be #bin/bin/bash, so you can just commit that to memory. The commands define what the script actually does. These will be dependent on the task at hand. And the exit code that is given off by the script's exit statement lets the shell know whether the script ran successfully or not. In short, an exit code of 0 means a successful run, and a non-zero exit code means an unsuccessful run. You then learned how to add comments to your scripts to explain its functioning to other people who might want to use it, as well as to yourself long after you've forgotten what the script does and how it works. Alongside inline commenting to explain your code, you learned that there are also 5 professional components that you can add into your script: the author information, the created date, last modified date, script description, and script usage. To add a comment, you simply started a given line with the hash symbol. We then looked at how to give your scripts appropriate and secure permissions using the chmod command and a cool website called permissionscalculator.org. You use permissionscalculator.org to find out the appropriate octal code to use with the chmod command for any set of permissions you might want to give a file. Unless you have a particular reason, we advise for security purposes in this course that, as a default, you give read, write,